Good afternoon. So today we are going over notes 4.4, solving rational expressions. So a rational equation contains one or more rational expressions. To solve rational equations, we want to clear the fractions first. Then we solve like a regular equation. So first you want to check though, is it a proportion? Then we cross multiply. So a proportion is a fraction that's equal to a fraction. So example 1, right, that is a proportion. So we will cross multiply. But before we do that, right, we're solving an equation. So just like we did in 4.1, we have to talk about excluded values. You know, what can make our denominator equal to 0? Then you can't have an equation. So in this case, right, what would make x plus 2 equal to 0, right, would be negative 2. So x can't equal negative 2. So we got to keep that in mind. So it's a proportion, so I'm going to cross multiply. So 4 times x minus 7, and then 1 times x plus 2. Distribute. So 4x minus 28, x plus 2. Now, since I cleared the fractions, I just solved the linear equation. Excuse me. Get x on one side, everything else on the other. So here I'm going to add 28 and subtract x. So 3x equals 30, divide by 3, so x is 10. And x is not equal to negative 2, so I'm good. Okay, example 2, same idea. Right? It's a proportion, it's a fraction equal to a fraction, so cross multiply. But before we do that, we want to worry about the values that make our denominator equal to 0. So x cannot equal 0. And then we have x squared minus 3 equals 0. So add 3, square root. So x cannot equal plus or minus root 3. So cross multiply, 3 times x squared minus 3. Right, multiply diagonally across, so that's 2x squared. Distribute, so 3x squared minus 9 equals 2x squared. So I do notice that there's x squared, and you're going to see this a lot in this unit. When you see x squared and you're solving, you should be thinking, okay, that's a quadratic. Easiest way for us to solve quadratics is usually factoring. So let's put it on one side, set equal to 0, and try to factor. So subtract 2x squared. You get x squared minus 9 equals 0. Factor x plus 3, x minus 3. So just like we've done numerous times, x plus 3 equals 0. Subtract. So you get negative 3. X minus 3 equals 0. Add 3. So you get 3 and negative 3. That's not 0 or root 3. Or negative root 3, so I'm good. Okay, now when you get to example 3, now that is not a proportion. It's not like the last two. It's not a fraction equals a fraction. There's two fractions on one side. So this, I have to clear fractions. How do you clear fractions? You multiply by a common denominator. So we're going to figure out the LCD, so we don't have to simplify as much. So what number does 2, 4, and 4 divide into evenly? 4. The largest power of x is x to the first. So I'm going to multiply the entire fraction by 4x. Right? Well, the entire equation is going to get multiplied by 4x. So that means multiplied by 4x, multiplied by 4x, multiplied by 4x. And now you're just going to simplify. So the x and x reduce. 2 goes into once and into 4 2 times. So you get 2. Here the 4x is reduced, so it's 5. Plus here the 4 is reduced, 3x. So now I can subtract the 5. So you get negative 3 equals 3x. Divide, negative 1 equals x. And we all forgot to check what the denominators can equal. In this case, x cannot equal 0. So we're good. There we go. So if you look at example 4, not a proportion. So I'm going to figure out what's the least common denominator. So what's the smallest number 2 and 1 divide into? 2. Largest power of x I have is x, so I'm going to multiply with 2x. So this entire fraction, both sides of the equation are going to get multiplied by 2x. So I'm going to multiply every term by 2x. So 5 over 2x times 2x equals 17 times 2x minus 6 over x times 2x. So the 2x is reduced, you get 5. This just becomes 34x. Here the x is reduced, so minus 12. So add 12, you get 17 equals 34. Divide by 34, so you get 1/2. And keep forgetting to do this. So make sure you remember what makes the denominators equal to 0 would be x cannot equal 0. So I'm good. 1/2 works. Example 5. So now this time it's a proportion, so I can cross multiply. So multiply diagonal across. Before I do that, I want to make sure I figure out what x cannot equal. It cannot equal -2, otherwise the denominator would be 0. So cross multiply, you get x minus 1 times x plus 2. On the right, you get x plus 2 times x squared plus 2x minus 3. So we're going to have to combine like terms eventually, so we'd have to multiply. But notice they share the same multiple of x plus 2, that same factor. So eventually that will reduce away. You can actually simplify that. So the x plus 2's can be reduced. So now you have x minus 1 equals x squared plus 2x minus 3. First thing that stands out to me is the x squared. Anytime I've seen x squared, I'm thinking, okay, I know it's a quadratic, so I'm going to put everything on one side and try to factor it, because that, for most of us, is the easiest way to solve a quadratic. So I'm going to move the 1 and the x over. So I have 0 equals x squared, add 1 over, so this would be -2, subtract x, positive 1x. And now I try to factor that. So see if I can factor the trinomial. So x times x is x squared. 2 is only 1 times 2. It's got to be a plus 1. So plus 2 minus 1. So now set each factor equal to 0 and solve. Add 1, subtract 2. So x equals 1. Perfect. That won't make the denominator equal to 0. However, though, this x minus 2, x can't equal -2, and we got x equals -2. We can't have that. So that -2 would make my denominator equal to 0. The fraction's undefined. So that's not going to be a solution. So that's a great example of why you have to check for excluded values. What makes your denominators equal to 0? Because sometimes you can get that in your solution. Because -2 is the solution to the quadratic. It's not a solution to the original problem, and that's what we're solving. Example 6, again, not a proportion this time. So we're going to have to figure out something to multiply by to clear the fractions. So the least common denominator. So if I multiplied everything by x plus 1, that would only clear the first fraction. So I also need x plus 4 to clear the other two fractions. So that is going to be multiplied by every single fraction. So hopefully we get to be able to do this visually, so we can do some of this in our head, so we don't have to write all this out. So it's x times x plus 1 times x plus 1, x plus 4, plus 3 over x plus 4 times x plus 1, x plus 4 equals x plus 3 over x plus 4 times x plus 1, x plus 4. I'm hoping that we can visually start to do this without having to write all this out, that you can do some of this in your head, because that way we don't have to write that big equation out every time. But for the first few times, you're going to want to do it until you can kind of do it in your head. So here, the first fraction, the x plus 1's reduced. So you get x times x plus 4, no longer any fractions. Here, the x plus 4 is reduced. So 3 times x plus 1. Here, the x plus 4 is reduced. So you have x plus 3 times x plus 1. So I'm hoping that we could eventually go just to this step so that you can do some of that in your head. So you don't have to write all that entire red equation out. So distribute. So x squared plus 4x plus 3x plus 3. I'm going to have to distribute here. So x times x squared plus 1x plus 3x plus 3. And then I'm going to start simplifying. But notice, everything is going to end up going on one side or the other. But if you add or subtract, the x squareds will reduce. The 3x will reduce. The 3 will reduce. So right now, all I have left is 4x equals x. So you should subtract x, right? Because you're solving for x. You end up getting with x equals 0. And again, make sure you check what can x not equal. So in our case, x cannot equal -1 or +4, because that would make your either one of your three fractions denominators equal to 0. So we don't have that. We have 0, so we're good. So remember, LCD, and don't forget to check your excluded values. Because sometimes, like example 5, you might get one of those values in your final answer, and that doesn't work. Okay, moving on to the next page, example 7. So we got some weird notation. So just basically asking you to plug this into your equation. So you have 2 over f of x. Well, f of x is x plus 2 equals. So f of x is x plus 2. So plug that in. And then you have x plus 2 plus 6. Well, we can reduce 2 minus 2 just becomes x. So this is just x. Okay. So now, same idea. I'm going to multiply by my LCD. So if I do x plus 2, that'll get rid of all the fractions. So I'm going to multiply that by all three fractions. So this is what I'm talking about. Hopefully we can kind of start doing this in our head. So if you multiply x plus 2 times the first fraction, right, the x plus 2's would reduce. So all you would have left is 2. If you multiply x plus 2 by the other fraction here, the x plus 2's would reduce. Right, so all you would have is x. And then if you multiply it by the third fraction, you would end up with 6 times x plus 2, because nothing reduces. So that's the part I'm hoping you guys can start kind of doing in your head, so you don't have to write it all out. So distribute the 6. So we get 6x plus 12. All right, combine like terms. 7x plus 12. So I'm going to subtract 12, so I get negative 10 equals 7x. Divide, we get negative 10 over 7. So there we go. And again, what x cannot equal is what's going to make the bottom of the fraction denominator equal to 0. So in this case, that would be negative 2. So I'm good. Okay, example 8. So very similar to example 7. Right, I need to find an LCD, so I'm going to factor the denominator first so I can figure out what needs to be multiplied. So this would be 2 and 5, so plus and plus. So my least common denominator, if I multiply x plus 2 that'll take out the first fraction. If I just do x plus 5, that'll take out the third fraction. I got to multiply by x plus 2 times x plus 5, and that will reduce all three fractions. So multiply this by the first fraction, the third fraction, the second fraction, and the third fraction. And that's going to reduce all my fractions. So doing the first fraction times my x plus 2, x plus 5, right? The x plus 2's would reduce. So all you would have is x times x plus 5. Plus, okay, now I'm doing the middle fraction here, right? The denominator would reduce with all of that. So all you would have left is 3. And then the last fraction, right? If you multiplied, just the x plus 5's would reduce. So all you would have left is 3 times x plus 2. So now I'm going to distribute. So x squared plus 5x plus 3 equals distribute 3x plus 6. So I do notice that there's an x squared. So I'm going to try to get that by itself. So I'm going to subtract 3x over. So that's 2x. And I'm going to subtract 6 to get minus 3. So now I'm going to factor that, hopefully. So we have x times x. 3 is prime, so 3 and 1. It's a plus 2, so plus minus. So set each one of those equal to 0, each factor, like we've been doing for unit 2, unit 3. So we get 1, and we get negative 3. And x cannot equal, right, negative 2 or negative 5. So we are good for both answers. Okay, example 9. So they give us two functions, and they ask us to solve f minus g of x. So that's f of x minus g of x equals 0. So 4 over x plus 2 minus 6 over x squared minus 4. Now, before you start trying to find a common denominator and multiplying, right? What if you just move one fraction to the other side? Would that create maybe a proportion, and then we could just cross multiply? So if I took this fraction here and moved it over here, now I'd have 6 over x squared minus 4. Now it's a proportion, right? Multiply diagonally across. So 4 times x squared minus 4. 6 times x plus 2. So you get 4x squared minus 16 equals 6x plus 12. Right? Again, x squared. So I'm going to put everything on one side. Right? So subtract the 6x. Add the 12. So you get minus 4 equals 0. Notice all three of those numbers are divisible by 2. So I'm going to divide by 2. So 2x squared minus 3x minus 2 equals 0. Now it creates something that I can hopefully factor. So let's see. 2 and 1. Right, 2x, 2x, 4x, 1x, that goes 3, good. So it's got to be negative 3, so negative plus. So x equals 2. Right, 2x plus 1 equals 0, subtract 1, divide by 2, so negative 1/2. So there we go. And we want to make sure we check our solutions, so x cannot equal negative 2. That makes the left fraction 0. And x squared minus 4 is a difference of squares, so it would be -2 and +2. So x can't equal -2 or 2, which, oh, look at that, we got +2. So that's not a solution, it's only the -1/2. So that's why you always have to remember to check your extraneous solutions. What makes your denominators equal to 0? You got to remember that. So sometimes you get those solutions. And again, that is technically a solution for my factored quadratic, but not the original equation. And that's what I'm solving. So it's just the -1/2. So remember, rational equations is a proportion multiplied diagonally across. If it's not a proportion, find the common denominator, multiply by every fraction. The goal is to get rid of the fractions so you can solve, and it's almost always going to be either a linear equation or a quadratic. Make sure you answer the essential question by writing a 3 to 5 sentence summary at the bottom of your notes here. Once you're done that, you're done with your notes. Have a great day.